Good morning, children. Stay safely at home. So, I am starting the next topic of the first chapter, that is equilibrium of bodies. Alright? What do you mean by the term equilibrium of bodies? Equilibrium of bodies means that you are applying a number of forces on the body, but the body is either at rest or if it is moving, it will move with constant speed. Alright, this is known as, then we say the body is in equilibrium. I repeat, when you can say the body is in equilibrium, you are applying a number of forces on the body, but the body is either at rest or moving with constant speed. Means the body is having uniform motion. In that case, we say that the body is in equilibrium. So, what is the definition of the equilibrium of a body? That I have written here. When a number of forces acting on a body produces no change in its state of rest or state of motion. Okay? Then we say the body is in equilibrium. The body is said to be in equilibrium. Alright? Now, there are two kinds of equilibrium. Static equilibrium and dynamic equilibrium. Now, a body may have two kinds of equilibrium, static equilibrium and dynamic equilibrium. From the term static equilibrium, one can easily guess what it is. Static equilibrium means what? When a number of forces acting on the body is remaining at rest, not at all moving. Then we say the body is in static equilibrium. And dynamic equilibrium, dynamic term is related with motion. Means the body is moving. But how the body is moving? Body is moving with constant velocity. So, when a number of forces act on a body and the body moves with constant velocity, then we say that the body is in dynamic equilibrium. So, you see I have written now that what is static equilibrium and what is dynamic equilibrium. Static equilibrium is what? When a number of forces act on the body and the body remain at rest, then the body is said to be in static equilibrium. Then what is dynamic equilibrium? When a number of forces act on a body and the body moves with constant velocity. Here the body remain at rest and here the body moves with constant velocity. Then the body is said to be in dynamic equilibrium. Now, if we apply our concept of force in case of equilibrium, so what we are observing? In both the cases, either the body is at rest or the body is moving with constant velocity. We know that when a body is at rest, it means that resultant force acting on the body is zero. Is that clear? When a body is moving with constant velocity, it means what? If you apply a force on a body, then the body should have an accelerated motion. But if the body maintains the constant velocity, it means that resultant force acting on the body is zero. So you see, what is the first condition for a body to be in equilibrium, maybe static equilibrium or dynamic equilibrium, is that resultant force acting on the body should be zero. It means what? Suppose you are applying this kind of force on a body. Means you see all the forces, they are equal. And they are pair of forces, they are opposite in direction and acting along the same line. So here, although you are applying a number of forces on the body, but what is their resultant force? Net force, NET, net force, that is zero. So as the resultant force or the net force of all the forces zero, so the body, if it is at rest, it will remain at rest. Or if it is in uniform motion, it will remain in uniform motion according to Newton's first law of motion. Alright, so what we have got? What is the condition for equilibrium? The first condition for equilibrium, the net force or the resultant of all the forces acting on the body should be zero. Is that clear? Now, We are having this concept also that if a body is in motion, not necessarily that the body will have translational motion. The body may rotate also. Alright. Now, who is responsible to produce the rotational motion? Moment of force. So, if any part of the body is fixed, in that case, if the resultant moment of force acting on the body is 0, then the body will not have rotational motion. So, what is the second condition for equilibrium? That resultant moment of all the forces about the axis of rotation should be 0. Alright, now this topic, condition for equilibrium, is a very favorite topic of the question set is, and it is a frequently asked question in ICSE board exam. Okay, what are the conditions for equilibrium? So, I am writing it. What are the conditions for equilibrium? So, what are the conditions for equilibrium? The first condition is resultant of all the forces acting on the body should be 0. Okay, then what will happen? The body will not have translational motion. So, the first condition for equilibrium, actually it is giving the condition for not having translational motion. So, you can remember, girls, while discussing the translational motion, I told you that when a body can have translational motion, the first point was the entire body should be free to move. Second point was this, that resultant forces should not be 0. That I wrote in the condition for a body to have translational motion. And here, this is the condition not to have translational motion. That's why the resultant of all the forces should be 0. If the forces is not 0, then the body will have translational motion. Alright, now come to the second point. Second point indicates that this is the condition when the body will not have rotational motion. So, resultant moment of all the forces should be 0. Resultant moment of all the forces about the axis of rotation should be 0. Now, this one you can write as another statement also. If you see that total anti-clockwise moment, if it becomes equal to total clockwise moment, then what will be the resultant? Resultant will be 0. So, instead of writing this statement, you can write this statement also if you find it easy to remember and write that total anti-clockwise moment about the axis of rotation is equal to total clockwise moment about the axis of rotation. Alright, so these are the two conditions for equilibrium. Alright, and first condition, I repeat, first condition not to have translational motion, and second condition not to have rotational motion. Alright, because when a body rotates, then it is an accelerated motion. Is that clear? So, that's why you can say that these are the two conditions for equilibrium. Kindly learn it and remember it till the board exam is over. That these are the two conditions for equilibrium of a body. Now, this second statement for the second condition of equilibrium, from this one is separately is known as principle of moment. I hope you can remember in the junior classes you studied it. This what is the principle of lever? Then principle of lever is principle of moment of force. What is the principle of moment of force? When a body is in equilibrium, total anti-clockwise moment about the axis of rotation is equal to total clockwise moment about the axis of rotation. So, the second statement, it is also known as principle of moment of force. So, what is the statement of principle of moment? You must learn this also because it is also important and frequently asked question for board exam. That instead of getting the condition for equilibrium, you may get like this, state principle of moment. So, what is the principle of moment? When a body is in equilibrium, then total anti-clockwise moment is equal to total clockwise moment. In equilibrium, sum of anti-clockwise moments equal to sum of clockwise moments. Alright. Now, how you can verify it? The most common example is the physical balance. Alright. So, I hope you can remember the physical balance. Physical balance is what? It is pivoted at the center. Alright. And there are two scale pan at the two end. Alright. At the two scale pan. Now, what is the working principle of a physical balance? What we do? We keep some substance here. Suppose we have kept a substance of mass M1 here, and we are keeping some weights here, and then you will observe that when the rod of the physical balance, it is horizontal, it is in equilibrium, neither it is moving up or down, then we consider that weight of the left hand pan and weight of the right hand pan, they are equal. And as we know, weight is equal to how much? Mass into acceleration due to gravity. So you see, if you consider the left hand pan, a weight of M1G acting, and here a weight of M2G is acting. Alright, so if you consider this length is L1, this length is L2, then you see this force, okay, according to principle of moment, as it is not moving. Then you see what is the direction of this force M1G. If I turn it towards the point of rotation, it is anti-clockwise. So you see what is the anti-clockwise moment here? It is the force, that is the weight of the body, into its distance from the axis of rotation. So what is the distance? L1 equal to the moment of the other force. So what is the other force? Moment, it will be the weight acting multiplied by the momentum. So it is L2. What is the direction? Just see it. You keep the point at the point of rotation, turn it towards the point of rotation. In which direction it is coming? Clockwise. So you see, this is anti-clockwise and this is clockwise. Both are equal. Why both are equal? Under which condition they are equal? When the balance is in equilibrium. So when the balance is equilibrium, you are getting W1 into L1 equal to W2 into L2. Now W1 is how much? M1G, and W2 is how much? M2G. Now you have seen in a perfect physical balance where no frauding is there, L1 and L2 they made equal. L1 and L2 they are made equal. Sorry, L1 and L2 they made equal. So you see from both the sides you can cancel L1, L2 and G. So what you are getting? The mass kept on the left pan is equal to the mass kept on the right pan. So this is the working principle of physical balance. Rather, by using a physical balance, one can verify the principle of moment. Alright. So that's all about the equilibrium of a body.